Hi everyone, I am Karen Blako and I will take you through the hygienic design aspects for the idle and drive end of a conveyor. In this session, we will cover motors, shaft and sprockets, specific for modular plastic belting as well as thermodrive. Then some thermodrive specific components like position limiters and containment blocks, and finish off with scrapers. There are different types of motors, for instance gear motors or drum motors. Gear motors are available in stainless steel, which are excellent for instance, wet environments, eliminating the effect water and chemicals can have on the painted version. This applies to the principle of material compatibility, which is principle number 2 of hygienic design. The painted motors can be a very good option. Just be mindful that a coating or paint will fill over time, and its integrity will need to be monitored. From the hygienic design perspective, a stainless steel motor or a drum motor would be preferred. The picture on the top left shows an example of a stainless steel motor. The top right picture shows an example of a painted motor with cooling fans. As for drum motors, be mindful that the connection between the sprocket-shaped surface and the motor can also slightly loosen over time. And also here, its integrity will need to be monitored over time. Compared to a painted motor, this will most likely last a lot longer. As for motors, there is some important things to take into account. Other than drum motors, they will need to be placed away from the product zone. And that does not only count for the conveyor it drives, but also for any equipment or conveyors it connects to. We often need to place safety guards depending on the specific safety regulations. Safety guarding can be designed in many different ways and actually can become a sanitation challenge or even a micro-harborage point. Therefore, it's very important to create a design that is as cleanable as possible. For example, a design with slotted holes as shown in the bottom right picture. The slotted holes allow us to look inside and spot any remaining debris. Allowing toolless removal by sanitation and integration into the SSOP, Sanitation Standard Operating Procedure, will ensure also this component is cleaned effectively. Safety guarding can, for instance, have sensors to shut down the system when removed. Also, the sensors will need to be integrated in the sanitation and maintenance programs. All in all, any guarding will need to be designed with the same principles in mind. Other than a drum motor driving the belt directly, any other motor is in place to drive a shaft, which will have sprockets to drive the conveyor belt. Any of these drive systems allow it to be a low-tension system, where a drum motor is basically a full-width sprocket with the motor inside. There are also full-width sprocket designed specifically for the Introx thermodrive belt that are driven by a traditional motor from the outside. An example of such a full-width sprocket is shown on the top left picture. The benefit of this full-width sprocket is similar to a drum motor, eliminating the sandwich areas between the sprockets and the shaft. Also here, be mindful of the connection between the shaft and the inside of the full-width sprocket, and monitor its integrity over time. Another hygienic sprocket option are angled sprockets. These so-called wobbly sprockets will change the touch point between the belt and the sprocket as it goes around. This allows a spray bar that is placed at the inside of the conveyor to spray the complete inner surface of the belt and not have any dead spots where traditionally the sprockets are placed. When using sprockets, any sprockets, their design is also of influence. Having cleaning windows in sprockets, the large openings, will allow the water spray to go through the sprocket and reach more areas on the inside of the conveyor belt. An example of a sprocket with cleaning windows, as well as the angled sprocket, is shown in the picture on the top right. Sprockets will also need to be kept in place, and this can be done with retainer rings, as shown in the bottom right picture, or by using the very hygienically designed sprocket spacers, as shown in the bottom left picture. These will still allow for cleaning the shaft. Thinking through the design of a drive end of a conveyor, we need to consider accessibility for cleaning and sanitation, and not having niches or harborage areas where soil can build up and not be effectively cleaned. Thermodrive belts will require what Introx calls position limiters. to ensure sprocket engagement and allowing for the zero tension system to operate. Any position-limited design will require a solid material and needs to be compatible with the product, environment, and cleaning process. Where possible, a toolless removable design allows for sanitation to remove the part and clean the part as well as the frame it is attached to. The top left picture shows the design that needs a screwdriver to remove the limiter, where the picture on the right has a simple and specific tool. Either way, we need to allow for cleaning of the sandwich area that is created by the connection point between the position limiter and the frame. Like any component added to the conveyor, we want to limit lap joints, or so-called sandwich areas. Any component in touch with the belt will need to have a product contact surface texture that allows for effective cleaning, as well as not damage the belt surface it is in touch with during operation. Like position limiters, containment blocks are thermodrive specific parts. They make sure the belt stays within certain parameters, and the same principles apply. It needs to be of a solid and compatible material. Toolless removable design is preferred when it comes to sanitation, and we want to avoid or limit any lap joints or fasteners. Remember, where there is a bolt, there is a sandwich. Furthermore, the component needs to have a product contact surface texture to again allow for effective sanitation as well as not damage the belt it is in touch with during normal operation. Scrapers are designed to remove product off the belt that might not naturally fall off with gravity. Think of sticky products like dough or smaller items like meat slices or leafy greens. Also here, the principle is to have a toolless removable for sanitation to be able to remove it and effectively clean the scraper. As the scraper is in direct contact with the belt, or very close to the belt, which is a food contact surface, we need to make sure the material is compatible. Compatible to the environment, the product, and the cleaning practices. Also here, we need to make sure that the scraper will not damage the belt surface. When we design scrapers or any component to the conveyor, we want to simplify the design as much as possible and have no or limited lap joints or so-called sandwich areas that can become a hard bridge area which cannot be effectively cleaned. Thank you very much for watching and listening. I hope you can use this information going forward, and please don't hesitate to reach out for more information.